Since I know that some of you aren't going to want to go back to the previous video, I'll just put in an appendix to show you how to evaluate the limit as the limit as n approaches infinity of 1 over 1 plus n to the n. Recall, by the way, that this limit it's just a rewriting of n plus 1 over n to the n. We rewrite it this way by dividing n by n and then 1 by n separately, getting this form. Now, some of you will look at this and say, well, wait a minute, why isn't this just 1? After all, we have n plus 1 over n, and that's just going to be 1. And if I take 1 and raise it to the infinity, doesn't that just give us 1? The point is that this is actually a little bit greater than 1. It never actually gets down to 1. So we're taking numbers like 1.000001 and raising those to very, very large numbers. So the question, as with all limits that are complicated to calculate, becomes which one is going to outrun the other? Is the exponent of infinity going to become more important, or is the fact that the base is almost 1, is that going to be more important? And the only way to know this is to evaluate using the rules, and in this case the rule is L'Hopital's rule. So the way you do this is we write that L is equal to the limit as n approaches infinity of 1 plus 1 over n to the n. We then take the natural log of both sides, giving us that's equal to the natural log of L is equal to the natural log of the limit as n approaches infinity of 1 plus 1 over n to the n. We can then use the rule that the limit of a log is equal to the log of a limit, so that becomes the limit as n approaches infinity of ln 1 plus 1 over n to the n, like that. In other words, I can bring the limit outside this log in that way. So this becomes now limit ln of n is equal to the limit as n approaches infinity of, using a law of exponents, I can bring down this exponent n, sorry, law of logarithms, I can bring down this exponent n and rewrite that expression this way. This gives me an infinity times 0 limit, because now I have ln of something approaching 1, which is like 0. So I have infinity times 0, basically. That's a L'Hopital's rule form, because I can just rewrite this in this way. This is just going to be ln of 1 plus 1 over n over 1 over n. That gives me now 0 over 0, and I can use L'Hopital's rule directly. So that gives me ln of n is equal to the limit as n approaches infinity. I take the derivative of the top, that's going to be 1 over 1 plus 1 over n, and then times the derivative of 1 plus 1 over n is negative 1 over n squared. In other words, I need the chain rule when I do that. And then I take the derivative of the bottom. Derivative of 1 over n is negative 1 over n squared. These are going to cancel, and that gives me that ln of L is equal to the limit as n approaches infinity of 1 over 1 plus 1 over n. That equals, I can now substitute and get 1 over 1 plus 0, which equals to 1. So I now have that ln of L is equal to 1. I take e and raise it to both sides. I raise e to both sides of that equation, giving me L, the limit, is equal to e to the 1, or e. So that's how you find this limit by L'Hopital's rule.